If you buy the idea of parallax, and that's actually why the stars are so far away from us as we change our position in space orbiting the sun, they're so far away that they don't get scrambled, we actually then know that the stars seem to be pretty fixed. And they are fixed in sets called constellations. We all love constellations, okay? There are actually 88 very unequal constellations. So the nighttime sky is broken up into 88 parts. And there are different, I'm going to talk about the Western constellations, but as you might imagine, if you're in a different culture, you're going to see different pictures. So I think that is kind of an awesome thing. There are what was it, Stellarium that I talked about the other day. Stellarium, actually, if you go into the constellations menu, you can pick like Native American constellations and you get a different set. Okay, we're going to focus on 88. And so here they are, and here is what they mean. Now, do you have to memorize these? No, but actually, if you look through these, they're in alphabetical order. This is this is the name, and this is the meaning. Okay, this is the name, and this is the meaning. Some of these you're like, I've never heard of that. And as it turns out, actually, we are only privy to a portion of those constellations due to our latitude. Okay, so many of these, if you're into Greek mythology and you've taken any courses on that or just kind of looked into it, a lot of times those names in Greek mythology end up as constellations in the nighttime sky. That's not so surprising. If you end up ever out at the Whitty Observatory for public viewing, there is a person out there, let me give a shout out to, there's a person out there, I don't want to embarrass him, that is great at telling stories about the constellations, and the stories come from the Greek mythology. So one more thing with this part. Now, we said that let me put it this way. In science, sometimes we come up with something that's called a model. And the model isn't necessarily the way it is. It's just kind of a helpful way to say how things kind of appear they are or how things appear to work. And the celestial sphere is one of those. So the celestial sphere, it's not the real deal, so do not become afraid. In the celestial sphere model, this is the Earth, okay, and that kind of blue-looking thing that the Earth is encapsulated in is called the celestial sphere. And it works because on the celestial sphere, then, we put the stars. The stars are fixed on kind of the inside or outside, however you want to think of it, of the celestial sphere. The other thing about the celestial sphere, an important feature, is that we see the sun move across the celestial sphere, okay, throughout the course of the year. The sun moves on what is called a line called the ecliptic. Now, we talked about the ecliptic before in the context of basically kind of that frisbee that the planets orbit the sun on what we call the plane of the ecliptic. It's actually the same thing. So we have some features of our model, the celestial sphere, that has the stars imprinted on them. So our celestial sphere has a north celestial pole. It has a south celestial pole. It has an equator, our celestial sphere. The equator of the celestial sphere lines up with the Earth's equator. I don't know if you can kind of see that cute little Earth stuck inside there. And the reason this model is kind of useful is that, and I know it doesn't work this way again, but if we think of the celestial sphere as actually rotating, okay, moving around, rotating on its celestial axes, then that is kind of what we see. And I think the other day I called that diurnal motion. That helps explain the diurnal motion. Again, is it the real deal? No, but if we think of the celestial sphere kind of rotating, and on the inside is the Earth, okay, and that's what makes the stars appear to go counterclockwise throughout the night around Polaris. So I think I already mentioned the sun. Now, one of the things, the sun is on a line that it's a, I don't know what you'd call it, a line that goes a complete circle. Now that complete circle is actually tilted 23.5 degrees from the the celestial equator. So, and that 23.5 degrees, it coincides with the tilt of the Earth's axis of rotation.